Hi, now I'm gonna discuss sample size determination. So, so far we studied about allocating the samples and h for each, right? For given n. So that was the allocation. Now we are going to. So this is allocation. This is determination. So we want to find n itself. Okay. So in week 4 lecture, we have studied sample size determination on the simple number sampling. So let's review it first. To compute the sample size, we need a desired level of accuracy. The accuracy is often expressed in terms of margin of error E, which is defined as this, where alpha is the significance level in constructing the confidence interval. So from this definition, we can set E to be equal to, so we can set this one equal to half width of confidence interval, right? 1 minus alpha times percent confidence interval. Okay. So on the simple and the sampling, let's just review it. Okay. So confidence interval for t. What was that? On the simple and sampling. So that was something like this. Square root of the n square over n 1 minus s square t hat plus c alpha over 2 right? So that was the square root. Okay. So the confidence interval. So the equation, the half width is this one. So we want to set this to be equal to E. And that is, so that means you can okay, let's just do it one more time. S square is E over Z alpha over 2 squared. So that is n over s square over n minus n s square equals to E over Z. I mean that we already derived this before, but just to refresh our memory. Basically, okay. So now we are. So this is finally this is the equation for a sample size determination, right? So that is this one. Oh no, sorry. That's the total. This is so. Okay. The only thing is that we multiply both by c alpha 2 square. Square. Something like that. So one thing you can see that is that if this guy, so if this guy is actually positive, so if E is high, then n goes down, right? So the margin of error high means that we allow for wider confidence interval, which means low accuracy. So that means we may decrease our sample size n. Okay. For mean estimation, so if this is the mean, so theta is the mean, then this will be so we'll have this, right? We'll have here, and then the only thing we don't need n square, and then the only change will, we don't need this, we don't need this, we don't need this, we don't need this, right? So then we don't need this. So then we don't need this. So that is this formula. Okay. Sorry. Then sorry about that. So okay. So we will be n minus 1. So n minus 1. So that means n minus 1, right? I mean 1 over n. So 1 over n. That is the this formula. Okay. Now this is for simple random sampling. Now we'll study sample size determination for stratified random sampling. But for the sake of simplicity, we'll assume that the proportional allocation will be used. So once we assume proportional allocation, then things are easy because we can basically use a simplified formula, right? So that basically the same. On the simple random sampling, the only difference is this one. On the simple random sampling. Okay. So the assuming proportional allocation, we can just use SW square instead of the S square in the sample size determination formula on the simple random sampling. Okay. So that means the only difference, so for mean estimation, we now have S square, SW square, instead of the S square, right? And total estimation, we have n multiplied both sides. So this is exactly the same formula for simple random sampling, except that SW square is used instead of the S. So SW square is used instead of the S square on the simple random sampling. So that's easy. Now, what if the optimal allocation? So the formula will be a little bit more complicated because we have we no longer use we no longer use this simple formula. So here, proportional allocation, we have a simple variance formula, but optimal allocation, the formula will be a little bit more complicated. But basically, the idea is the same. We use this variance form for optimal allocation and then apply to the equation for equating the E equal to the half width of the confidence interval for that sampling design. But this is an advanced topic and maybe it's too much for this online course, so I will skip this part. Thank you.